Students, is my screen visible?
Yes, sir. Yes, sir. Yes, sir.
Programming environments, right? Basically, in order to execute the programs, we need some kind of environment where we can type up a program and compile the program, debug the program. If we want, we can trace the program. Okay, then we can run the program, and we can watch the inputs by giving different values while tracing. You know, all this kind of things. If available at one place, okay, then it will be quite helpful for the program. So we have generally, programming environments also being available based on programming languages. Like when you see Unix operating system, right? You see Unix operating system. I'm highlighting this. Unix operating system, right? As probably in earlier classes have discussed, that in Unix is the operating system which is developed in C, and C is developed in Unix. So then probably the environment is automatically built in Unix for C. So not only for C, in Unix, if you see, programming environment is built in, available for C, C++, okay, and now for Java also available. Right? You can perform shell programming, and perform, corn shell, bond shell, and all kind of thing, which are available as part of the operating. Nowadays, when you look at Windows 10 are coming up with Macintosh, or they're coming up as workstations rather, and they're coming up as a framework, of course. Uh, but earlier, if you see DOS is the disk operating system, which was invented by Microsoft founder Bill Gates as a part of his assignment when he was working as an employee at IBM, right? International Business Machines. So in that, if you see, okay, there was no direct environment available. So, for example, if I have to if I have to implement C programming, then I need to install some environment like Borland editor or Turbo editor. We used to do that, like we used to install. Fine. Then, of course, when you see, actually, Unix operating system before came into being, it was developed as Unix is an older operating system, and tool collections, we have a good number of tool collections. Unix was initially text-based. Where you have to write the commands and then get it executed. So common desktop, environment was there before. Then this desktop environment is upgraded to GNOME, that is graphical based, right? And now after graphical based, came into being with Unix. That has happened actually after Microsoft people, X Windows, and Macintosh people have come up with that, right? But still, if you see, Linux is more powerful from the system programming point of view, right? And for example, if you have to perform, programming, if you have to implement C program and all, in Unix, you have directly VA editor, Geo editor, right? So you can directly start off with the editors. like for example, if you want to implement with Java, if you want to implement Java programs, that you have different environments available, right? You have JBuilder, you have NetBeans, you have MyEclipse, Eclipse. So, a lot of IDDE tools. We call them as integrated developed environments, right? So most of the things will get integrated and provides quite handy to the programmer where you can perform all these kind of facilities. You can type, edit, copy, cut, paste. You can create it as a file and again open it after a while and then compile it and then execute, trace, debug, all such kind of things you can probably do. Right. So similarly, for Visual Basic, Visual C++, we have Visual, uh, Studio.NET environment where you can perform all C hash, Visual Basic, with JavaScript, and all that. Right. So these are all programming environments, right? This must be available in order to execute your program with the help of any programming language, right? Before going to this, what you need is you need an operating system as well, right? You need an operating system. Okay, so the operating system will act as an interface between the user and the hardware, okay, which will allow the user to interact with all the system programs available on the machine to execute and then to get it performed for the user rather, right? So here generally what happens when you switch on the system, let me just come from the beginning now, right? When you switch on the system, basically you may see that some kind of statement comes on the black screen that the system is booting rather, right? Most of you may have observed that booting kind of course, on desktops, on the earlier system, we used to have that kind of thing, but now in laptops and all, we don't find all these kind of things, right? But if you observe, if you could have observed in the older systems, right, then that booting word which comes, right? What do you mean by booting actually here, right? Any one of you can probably answer this. Shreyasri, Nidesh Rao. I'm not familiar with many of the names. Probably I'll slowly familiar with once I start interacting with all of you. Rather, any one of you from class can give me the answer for this. What do you mean by booting, right? Yes.
Restarting the computer.
Yes. You said starting the computer. Yeah, computer is being started. But what happens actually? I mean, how does the computer get started rather, right?
So it restarts completely from the CPU along with the processor, everything.
Yes. Restart the CPU, you say, fine, that's good. But then, in order to get started, probably again a program is needed rather, right? So there is a bootstrap loader program which is available in the lower part of the main memory, right? If you see the uneven architecture here, yeah. So yeah, this one. If you look at this is the memory. So in this memory, in this memory, the main memory, which you call it as, right, random access memory sometimes, right, preliminary memory, where actually the lower part of it will get equipped with the operating system programs, and the upper part where probably the user programs will be dumped rather, right? So here, but there will be no operating system programs, initially when the system is shut down, right? Rather. So where these operating system programs, then there is a hard disk here. You find hard disk, right? So in this hard disk, actually, these programs, operating system programs are available. But then how they are going to be loaded here, right? In the RAM, lower part of the operating system. Only when operating system programs are readily available in the memory, only then you can start your system. Because when operating system is not started, you can't do anything, right? Because that is the interface between you and the computer. It will take your request to carry it out with the computer, rather, right? So what happens is there is one bootstrap loader program, okay, right here, bootstrap loader program. In addition to this RAM, you will have a ROM, random read-only memory. Okay, ROM stands for read-only memory. RAM stands for random access memory. Right? Random access memory is even said to be the volatile memory, or temporary memory, because the data will be available only until the execution. Once the system shut down, then this all will be flushed off. The entire data which is available in the RAM will be flushed off, right? So there is a ROM again. You find as part of the memory, okay, as part of the CPU or part of the computer, rather, right? Which is quite sometimes it is part of the CPU or it is very much nearer to the CPU, right? So this ROM, in this ROM, you will have this bootstrap loader program, okay, in this ROM. So this bootstrap loader program, what exactly it does is when the computers gets switched on, okay, when the computer gets switched on, the entire hardware of the computer will make the program counter register. Will make the program counter register. Right here, PC generally there are certain set of processor registers, and you have certain set of memory registers as part of the CPU, right? So this program counter register will hold the address of the instruction to be executed. So the CPU, right? In CPU you find control unit and arithmetic logic. A control unit is designed either through hardwired or microprogram control unit. So if it is microprogram control unit, then you have a ROM inside, again ROM, again this kind of ROM inside you find. This ROM, read-only memory of control unit, will be programmed to initiate the sequence of micro operations to be executed. Right. So the control unit, of course, will provide the functions by sending the required signals to the hardware devices and make the functions available for the execution, right? Based on the user instruction that is being specified. User instructions are available in the memory, right? So now what happens, this program counter register. This program counter register will hold the address of the instruction to be executed. What CPU does is, CPU is going to execute the instructions one after the other, which are being specified by the PC. Okay. Just specified by the PC. So what happens when you switch on the system? The entire hardware will make the PC to point to the bootstrap loader program, okay, is available as part of the ROM, read-only memory. Then what happens is the bootstrap loader program get executed. It means when you switch on the system, what is happening? Bootstrap loader program is being executed. That is what is called booting or starting the system, right? So what happens? This kind of adjustment is set by the hardware designer that when the system is switched on, the program counter should point to the first instruction of the bootstrap loader program. So now when the bootstrap loader program get executed, what actually the bootstrap loader program does is, right? What exactly the bootstrap loader program does is, it will start, it will start transferring the operating system programs, or the other way around, I can say the loading. It will load the operating system programs from hard disk to main memory, right? From hard disk to main memory, right? Which is your main memory. So the location specified, as I said, lower part of the memory, the location specified by the hardware designer for the operating systems. Here, what happens? The bootstrap loader program will load all the operating system programs. Once the operating system programs are loaded in the lower part of the memory, then they start executing. Okay, operating system programs are available as executable files, right? RDLL files, right? They are ready to provide the services. Okay, so then what happens is, the operating system programs when get executed here, right? There is, one environment is going to be created, which is said to be the kernel mode or supervisor mode. Okay, kernel mode or supervisor mode. So the kernel mode is running. So what that kernel mode is running with operating system programs. So once the operating system programs get loaded from the hard drive to the main memory with the execution of the bootstrap loader program, then all these programs, since they are in the executable form, they start running. So always, these operating system programs runs in the background, right? In the kernel mode or the supervisor mode, right? That is the reason why we call this, processes. We call this processes in the sense the programs which are running in the background. There is a difference between process and a program, right? Program is nothing but a set of instructions. Program is nothing but a set of instructions, whereas process is the program in execution. Program under execution is the process, rather, right? So the processes running in the background, right? Who are running in the background? Of course, operating system processes running in the background. Once the system is switched on, okay, those processes are said to be the daemon processes, right? Those processes are said to be the DAEMON, right? DAEMON, daemon process, right? Process runs in the background, right? And these processes are ready to provide you the services, right? Provide the services to whom? The user, rather, right? What kind of services you need? If you want to work with file, you need to create a file, you need to maintain a file, you need to write into it, you need to read into it, you need to update some modifications you want to do, you you want to trace, you want to so what all the file operations that you can do comes with file management, right? So there is a set of programs running in the background by operating system to provide you the file management services. Similarly, if you want to interact with input device or output device, then IO management services required, which are also running as part of the operating system programs in the background for you, right? You can enable them anytime. You can make use of them anytime when you require that, right? So similarly, process management. Now, if you're working with multiple processes, because nowadays you can see all the operating systems are multitask operating systems, and you run more than one process at the same time. How then this multiple processes are going to run concurrently with a single processor, right? there should be some kind of management is needed that is part of the process management, which is also one of the service that is being provided by the operating system. And you need different resources at the different time, right? You need different resources at the different time. You need sometimes a CPU, you need sometimes an input device, you need sometimes the output device, right? You need sometimes printer, you need blah blah blah. So resources, how the resources are going to be allocated to you, right? Of course, the operating system is going to provide you the resources required as and when you request, right? So these are as part of all this, your required services. Operating system is running in the background to provide you services with the help of these daemon processes, rather, right? So here, so once you start, the what do you call operating system? Sorry, once you switch on the system, then operating system is loaded into your RAM, which is nothing but booting. Now all the services it is trying to provide you by running the services in the form of daemon processes. So, and they are all running in which mode? Kernel mode or supervisor mode, right? There is another mode, right? You find where the user is going to give his request in the form of a program to the computer. This mode is said to be the user mode, right? This mode is said to be the user mode. So, yeah. So,
Sir,
yeah.
so the operating system files always run in the supervisor mode in every situation, or only when we reboot the system?
No, always they run in the supervisor mode only. If you want to avail the services, you make a request to the operating system, rather, right, with the help of a program, which is set to be the system call, right? In C programming, we call it a system call, right? With the help of system calls, you can probably avail the operating system services by switching from the user mode to kernel mode. You have to get the service. Of course, that all being taken care by the operating system. So when you invoke any system call, what happens? The control will be transferred from the user mode to the kernel mode, and the requested service will be processed, and whatever the output needed to the user, that only will be sent to the user. So it means the switching between the user and supervisor mode is going to quite happen. It's going to happen continuously. So when switching between these modes are being happened, what happens is some kind of delay is going to be done, because when, say for example, if you have invoked some system call, you are invoking it from the user mode. So in order to get process, you need to switch from this user mode to kernel mode. So, but before you switch, you want to save the status of your user program, so that when you come back from the supervisor mode, you can start from the instruction where you left off, rather, right? You don't want to execute again right from the beginning, right? So this particular address is said to be the return address, right? Generally, along with all the processor registers and flip-flops together, we call it as a processor status word or program status word sometimes, right? So PSW. So this PSW we push onto a stack. There is a data structure stack to perform our required switching process here. Okay. Probably you may be studying data structure as well. There you will be studying about stack. Stack is a data structure based on last in first out concept. So if you see the memory which I have shown you, RAM. So this RAM consists of this RAM. Initially, it was divided only into two parts. Okay, initially it was divided into only two parts, but then later it was divided into three parts now. When initially it was divided into two parts, one part was stored with the program, the other part was stored with data. But then later it was extended with three, where another part equipped with the stack, because stack all the time you require here, rather, right? because switching between the user to kernel mode is going to happen all the time. So to store the program status, what are the return address, while switching is always required. So for which, of course, you need some kind of memory. So part of the memory is being reserved for stack. Stack is not only used for this kind of process, but as well there are a lot of applications of stacks. Like if you are working with mathematical expressions, basically mathematical expressions you give in the infix form, right? You give as a plus b into c, right? Like this you give. But then computer does not understand if you give like this. So this will be either converted into prefix form or postfix form. Prefix means writing the operator first and then operand, right? This is the prefix form of the a plus b into c here, right? So, and when you have multiple operators, operator precedence will be taken place. So into is will have more precedence, so b into c will be carried out first. So to represent this in the prefix form, how do you represent this b into c into bc, right? This whole become now value rather, right? Then you have a plus, this whole is a operand now, a plus this. Then how do you perform, how do you convert this into prefix? You say a plus, in prefix form, operator first, then you write the left operand, then you write the right operand in the prefix form is into bc, means plus a into bc. So this is how you will store in the computer. So as part of the compiler, there are certain programs available which will convert this prefix form into infix form into either prefix form or postfix form. When you say postfix form, when you write the operator next, first operands, then if you write the operator. Fine. So to convert this infix to either prefix or postfix, also you need stack. Of course, you study in data structures, right? In applications of stack. So there are a lot of applications. For function, a function call, for recursion, for what do you call this, expression evaluation, expression conversion, or many of the gaming programs, if you see, right? All gaming programs based on last in first out approach. You need a stack. Even you see the browsing. How do you do the browsing? Right? It's based on last in first out. When you are navigating from one page to another page, right, continuously, and you want to go back, you have a back button on the left top corner, right? You just click on back. You will come to the back page. You can see the order is last in first out. Is it not? Are you going to get the first page when you say back? No, you just get the inserted before this rather. It means last in first out. So this is also implemented based on stack. So a lot of applications are there of stacks. There's a reason why it has been made as a part of the memory itself, right? So your memory now, if you see, you find in one part you find programs, another part you find the data, and another part you find this stack, where the stack operations are going to be performed rather, right? So here yeah. So what I was telling is when the system is switched on, the programs, operating system programs get loaded and they are running in the background, ready to provide the services. Then user can now submit his request. Now, the user request is going to be carried on. So user instructions, right? Basically, user is going to provide request of a program. Program is a set of instructions, right? So these instructions are going to be executed by whom? CPU, of course, right? Going to be executed by CPU. So here, as I told you, there is a program counter register who will specify the address of the instruction to be executed. So the program which you give initially, that is stored in the main memory, right? It's available in the main memory. So by storing program at what part, one part, that is instruction, set of instruction. And then you have the data. Data is at another part, or the operands, right? Because memory is having three parts, no? In one part is store the programs or instruction, another part is store the data or the operands, and another part you have the stack, of course, right? Okay, stack for stack operations. Now, the program counter register has to specify the instruction to be executed by the CPU. CPU will execute only those instructions which are specified by PC. It means now what happens is the PC now point to your instruction, right? It means the address of the first instruction of your program must be available in PC, right? This is called fetch phase, right? This is called fetch phase. So fetch the instruction and decode the instruction, then and then execute the instruction. This is the cycle of the instruction. Show you here. Slide is there. Yes. So how the execution of your program is going to be done, right? The instruction cycle consists of fetch, decode, and execute. Okay, in pipeline processor, probably the different phases that I'm talking about. In pipeline processor, it could be 6 levels, right? Fetching the instruction, then calculating the decoding the instruction, calculating the effective address, then fetching the operand, then execute the instruction, then store the result, right? But otherwise, in general, for many of the smaller computers, you just say fetch and execute. It will fetch the instruction and execute. So fetching the instruction, from where it will fetch the instruction, the PC when gets the address of your first instruction, right? So you have the instructions here. Yeah, yes. Now specifying the first instruction because it is holding the address of this instruction. When PC is holding the address of this instruction, now CPU is going to execute that particular instruction, right? Because it takes the instruction specified by the PC to execute that, right? So initializing the program counter is the first step, you can say, right? Initializing the program counter. So program counter initialization is done by giving assigning the address of your instruction, right? So now program counter get equipped with the address of your instruction. Then what happens? CPU start executing that instruction by fetching the instruction pointed by the counter. So fetching the instruction is nothing but getting the instruction from the memory. In memory you have, right, all the instructions and data, right? You have the instructions and data. So you have initialized the program counter first. It means the computer itself is going to take care of it. Rather, right, when you submit the request. So now the CPU is going to fetch the instruction specified by the program counter from the memory, because fetching is going to be done from where the instructions are available, in the memory itself. So fetching is nothing but accessing the memory to get that instruction, right? Once it gets the instruction, what happens? It starts executing it. But in addition to the fetching here, immediately it increments the counter. It increments the program counter, so that the program counter will be equipped with the next instruction address, so that the cycle when finishes for that current instruction, when CPU comes back, it is ready to provide the address for the next instruction to be executed, right? So these two things will be done simultaneously. Fetching, in alliance with fetching, the increment of the counter can be done, since increment is just a control signal associated with the register. If you see the program counter register, if I draw like this, the program counter register will have certain control signals here, right? One of them is the increment. One of them is the increment, INR. You have clear, you have increment, okay. So, and load you have right like that. So when the increment control signal is enabled, automatically program counter get incremented. Who is going to enable this? Control unit, right? Control unit is going to enable the control signals of the processor registers and provide the address of the processor registers, by giving the inputs to the multiplexer in the common bus system, and it enables the load control signal of the respective processor register, into which, of course, the data has to be loaded. Right? These all things are going to be done by the, of course, the what do you call, control unit, right? So these two things will be done at the beginning. Then next is you have what? Decode instruction, right? Decode instruction. Second part is decode instruction. This is decode. Because instruction consists of, if you see the instruction, format, instruction format, instructions are stored in instruction register. This is one of the processor register. So it consists of indirect mode bit here at the beginning. Then you find the opcode. Opcode specifies the operation to be carried out, right? For example, addition, then addition code will be specified here, right? Then you have the operand in the next one, right? Operand on which this operation has to be carried out, right? So it will decode. So the second phase of the instruction cycle is decode. So it separates this instruction with the indirect mode bit, and then opcode. Carried out, right? If it is addition, then adder circuit has to be enabled. So the control unit will take care of enabling that adder circuit, of course, right? And then next is we have, while carrying out the operation, if the operand which is specified here is with some kind of different addressing mode, indirect addressing mode. Indirect addressing mode means the operand is not available here, operand address is available. So taking this address, you go to the memory and then find the operand, right? So direct or indirect or immediate, you have different kind of addressing modes, right? Register, indirect, So if the addressing mode is not immediate, then it means the operand is not available here. In that case, you need to calculate the effective address. What do you mean by effective address? Effective address is the address of the operand, the actual address of the operand, right? So some procedure is required to calculate the effective address. That's the reason why the next step after decode in some computer architectures, you find this effective address calculation also, right? So once the effective address is calculated, you can go to the memory, the data part of the memory where you find the operand. So you just take the effective address, go to that data part of the memory, find the or fetch the operand. The fetch operand is also another part of the instruction cycle for some computer architectures, right? Because fetching the memory will always take considerable amount of time, right? Accessing memory, because it is not part of the system level, so it takes time to access it, right? So some architectures, when you can see, you find decode instruction, calculating effective address is another phase. Then you find fetching operand. Then you find the execute instruction, right? So likewise, you find 6 phases in few architectures, basically in pipeline architectures, in order to make the phases to be uniform so that they can be applied with segments and let them to be executed concurrently to achieve the good throughput. You will find, fetch the instruction, decode the instruction, then you find calculating effective address, then you find fetch the operand, then you find execute the instruction, then you find store the result rather, right? The storing, when you are storing also, you need to access the memory again. So accessing memory is taking considerable amount of time, so you can separate it from, normal course of operations rather, right? But otherwise, if it is a small kind of 8085 or 86 kind of processor, then you don't find these many phases. It could be just fetch, execute, sometimes fetch, decode, and execute, like how in this it is there. So what happens is, once the user has submitted his request, the instructions of his program are going to be executed sequentially, one after the other, and every instruction to be executed will happen by going through all these phases, right? What are they? Fetching the instruction, decoding the instruction, and executing the instruction. Minimum of 3 of these phases you find any of the architecture: fetch, decode, and execute the instruction, right? Fine. So if you look at the layered view of computer, when you look at the computer, you find the bare machine or the kernel, I say, right? Bare machine, the bare machine or the hardware, I can say, right? This is completely the hardware. Then over which you have another layer. You find micro instruction interpreter, right? As I said, if the control unit is designed with microprogram control unit, then you will have 2 memories, right? 2 ROMs. One ROM is, as I said, for the operating system programs to be loaded, and user programs, will be initiated from that particular process. But then there is another ROM you have, which is said to be the control memory, right, as part of the microprogram control unit, which initiates the sequence of micro operations to be executed, right? So that part you find, right, immediately over the what you call hardware, you find this micro instruction interpreter, and then you find the operating system. Your operating system, it could be a Linux, or Windows, or Motif, or Solaris and Solaris, or iOS, and all kind of thing. Then over which you find the programming environments here, right? These are the programming environments. They'll be available as part of as either in IDE, or it could be an API kind of thing. Nowadays, they are available as universal universal discovered, what do you call, integrated discovery kind of thing, right? UI IDE kind of thing you find, otherwise IDE, right? So the hardware at the beneath, bare machine, then you find the micro instruction interpreter, then you find the operating system, of which you find your C++, environment, or C environment, equipped with the compiler, right? So here, if I take an example of Unix operating system, in Unix operating system, your bare machine is the hardware is here. Then you have the micro instruction interpreter is here. Then then you find your Unix operating system. So now this operating system is ready to provide the services by running the daemon processes around, right? And let us say your C++ compiler or C compiler, Lisp interpreter, if you have, or Fortran compiler, or let's say, for example, C compiler here, right? So this, will be the next layer over the operating system, where your user programs get executed rather, right? So here the user mode is running, and here inside this you find the kernel mode or the supervisor mode is running, right? So this is the view, the layered view of a computer. Uh, yes. Um, so, in order to execute our program, right, what is that we need? We need a machine first. That is a bare machine. Yes or no? You need a bare machine first. Then you need, you know, the microprogram control unit, micro instruction interpreter unit. Then over which you need an operating system. Then over which you need, you know, over which you need the IDE environment, right? So in Unix, if you see, you find this IDE environment comes along with the operating system itself. We have VI editor, Joe editor, right? In after the desktop environment came into being, right? Then if you are probably want to execute C programs in Windows, then you need to install separately an IDE for it, rather, right? You have Edit Plus, you have Borland C, Borland C or Turbo C, and CC. We have different levels of the same, right, that you can install and then execute. But otherwise, with Unix, C, C++, and Java, all these programs can be directly executed. Because the operating system is itself is going to equipped with the compilers of these programming languages, so user can straight away start executing programs in it, rather, right? So other environments like JBuilder for Java, StudioNet for C Hash, Visual C++, and all that. Now coming to preprocessors, basically in C program also you have seen preprocessor, hash define, hash include kind of thing you may have used, right? The advantage of microprocessor is basically hash. Sorry. Uh, yeah, here you can see hash include, hash define. Generally in C program, you start with hash include stdio dot in, hash include conio dot in, right? So what is this hash here? This hash is the preprocessor directive, right? Preprocessor directive. It is directing to a preprocessor because after hash include, what do you write? You write stdio dot h. What is this stdio dot h? Basically, standard input output. Standard input output header file. It means all the IO related functions, whether they are file or console, they are available in stdio data in the form of executable one, right? In the form of executable one. So you can straight away just call them and get it executed for you. Like for example, printf, scanf. If you want. Similarly, if you are working with math library, you have math.h. So if you are accessing, like for example, sqrt, square root of a number, or sine function, cos function, any mathematical functions you want, you can probably go with math.h rather, right? Math.h. Fine. So what this directive is doing, it is directing this pre-processed functions available as part of the library. So of course they are not the part of the programming language, but without which you can't do the programming as well, right? You can't write your own printf and scanf, then you start writing your program. So you need some support to perform the programming as well. So preprocessors are essential to perform the programming. Similarly, this preprocessor concept has been in further languages extended to a great meaning. They are available as packages. In Java, you say they are available as packages, IO packages, right? So all functions along with it, objects are going to be stored in this particular what we call package. IO star. Star is a wildcard character here. You say In SA star, all the available objects can be made accessible in the program of IO package, right? So similarly, if I have, let us say, lang package, lang star, if I say all the available objects and respective methods will be available in my program. So without this what you call preprocessors and packages, also you can't execute your program. So in order to execute your program, what is that you require? You need a programming environment, right? Programming environment are being sometimes available as part of the operating system itself, or else you need to install, right? So first thing is, if you look at the architecture, if you look at what is that you need, we have seen that the bare machine is nothing but the hardware, right? This is the bare machine. Got it? Then you need control unit, then you need operating system, then you need the IDE, right? Integrated design and development environment, rather, right? So these all things you need, right? Only then you can go for executing, writing your programs and executing them, rather, right? So in addition to this, of course, you need preprocessor as part of the programming language that we have discussed, and then while executing, how this program is going to be executed, we have seen with the help of the architecture of a computer, right? The instruction cycle execution, right? How your program is going to be executed sequentially, one after the other, by going through the all phases of the instruction cycle, consists of fetch, decode, and execute, rather, right? And okay, this is your instruction execution, instruction cycle execution, right? And then one more thing that you need to be add on for few programming languages, that when the execution of the programming language is slower, like for example in Java, by adding JIT compiler, he is able to execute, increase the execution speed, because in interpreted languages, we said the execution speed is slower compared to the compiled programming languages, right? So this is all we have discussed part of this particular chapter. I'll just summarize what we have learned out of this entire 4 classes that happened so far. We have learned about we have studied the programming language, that is valuable for a number of reasons. It increases our capacity to choose the different constructs. We said it enables us to choose languages more intelligently. It makes learning new languages easier. We said most important criteria for evaluating programming language we have discussed, including reliability, writability, readability, and cost. Then what are the criteria which influences the language design? We have discussed, and the self-conflict, self-contradictory, evaluation criteria also we have discussed. And then we have discussed the machine architecture, and we have discussed the software development methodology, programming methodology, how the programming methodology has been shifted from the procedural approach to data-oriented approach after object-oriented programming came into being. Then we have discussed, then we have discussed the programming environments today, and its implementations, right? And the implementation of the programming languages also we have discussed before, like compilation implementation, interpretation implementation, hybrid implementation, and the different languages. We have just pointed out how the languages categorized based on the different paradigms, right? So programming paradigms we have discussed, language categories we have discussed, programming environments we have discussed. We have discussed computer architecture. We have discussed the programming methodology. We have discussed the reasons for studying the programming languages, concepts of programming language, and evaluation criteria. And we have discussed the design trade issues, and we have discussed the influences, the criteria which influences the language design. These are all what we have discussed as a part of this particular chapter. Now I'll stop my presentation here, and I want you to take the test at this juncture. If any doubts so far, you can probably ask me now, or else we can go for the quiz. Just open your classrooms. Open your classroom. Go to classwork. Go to PL quiz 4. Go to PL quiz 4. Nidish,
Yes, sir.
is quiz visible?
Just a minute, sir.
Sir, it's opening, sir.
Yes. You can take from now on 5 minutes will be given. Only 5 questions are there. All of you can please start.